Okay, so here's the thing. I accidentally calculated how long it would take for a black hole to absolutely delete you from existence. And the answer is way faster than it takes to sneeze. We're talking a nanosecond, 1/1000th of a second, the time it takes light to travel 1 foot. And today, we're going to experience it. Well, theoretically experience it because, spoiler alert, if I actually did this, there'd be no video. But here's the wild part. Scientists think that single nanosecond might feel like an eternity to you, and you might see things that would make Christopher Nolan weep. I'm talking about the birth and death of stars, the end of the universe, and possibly your 8th grade crush. Stay with me, this gets weirder. I'm Alex, and before we voluntarily unalive ourselves in the name of science, hit that subscribe button because if YouTube's algorithm is a black hole, at least we'll get sucked in together. Now, you can't just walk into a black hole. First of all, there aren't any nearby. The closest one is about 1,600 light years away, which means even traveling at light speed, you'd need to pack 1,600 years worth of snacks. But let's say we solved that problem with some sci-fi nonsense technology. We still need to pick our black hole carefully because they come in different nightmare flavors. You've got stellar mass black holes, which form when massive stars collapse and are typically 10 to 100 times the mass of our sun. These are the standard black holes, the ones that'll kill you quickest. Then there are supermassive black holes, the kaiju of the cosmos, sitting at the centers of galaxies with masses ranging from millions to billions of solar masses. The supermassive black hole at the center of our Milky Way, Sagittarius A star, yes, that's pronounced A star because astronomers are fancy, weighs about 4 million suns. For our experiment, we're choosing a supermassive black hole, and here's why. The bigger the black hole, the weaker the tidal forces at the event horizon. With a smaller black hole, you'd be ripped apart, spaghettified, as scientists adorably call it, before you even cross the point of no return. But with a supermassive black hole, you could theoretically cross the event horizon intact, conscious, and aware. You'd still die horribly later, but at least you'd get to tweet about crossing the event horizon first. We're building a theoretical spacecraft with sensors that can record what happens in that nanosecond: temperature, radiation, gravitational forces, and any weird quantum stuff that decides to crash the party. The spacecraft is essentially a high-tech coffin, but with better Wi-Fi. As we approach our supermassive black hole, things start getting trippy long before we reach the event horizon. First, you'd notice the accretion disk, a swirling disk of superheated matter orbiting the black hole at insane speeds, glowing brighter than 1,000,000 suns. This disk exists because black holes are messy eaters. Gas, dust, and sometimes entire stars get caught in the gravitational field, and as they spiral inward, friction heats them to millions of degrees. The radiation would kill you instantly, but we've got sci-fi shielding, so we're good. Next, you'd start experiencing gravitational lensing. Light from stars behind the black hole would bend around it, creating multiple distorted images. The black hole would appear as a dark sphere, not because it's a physical object, but because it's a region where light can't escape. Around it, you'd see an Einstein ring, a halo of bent starlight that looks like the universe did too much acid. As we get closer, time dilation kicks in. To observers far away, our spacecraft appears to slow down dramatically. From our perspective, though, everything feels normal. It's the rest of the universe that seems to speed up. You'd watch stars being born and dying in fast forward. Galaxies would spin like cosmic fidget spinners. And here's the mind-melting part. If you somehow looked back at Earth through a super telescope, you'd see civilization fast-forwarding. Empires rising and falling, climate changing, TikTok trends cycling through at hyperspeed. In the time it takes you to say, subscribe to the channel, millennia would pass back home, and we haven't even reached the event horizon yet. The event horizon is the ultimate no-takesy-backsies line in the universe. It's the boundary where escape velocity equals the speed of light, which means once you cross it, not even light can escape. And if light can't escape, neither can you, your spacecraft, your regrets, or that embarrassing thing you said in 7th grade. Here's the weird part. Crossing the event horizon wouldn't feel like anything special. There's no wall, no barrier, no cosmic welcome to your doom sign. From your perspective, you just continue falling. But from an outside observer's perspective, you'd appear to freeze right at the edge, your image getting redder and dimmer until you fade from view entirely. This is because of extreme time dilation. Time for you is moving so much faster relative to the outside universe that you'd essentially experience the rest of the universe's history in your final moments. Now let's talk about that nanosecond. The moment you cross the event horizon, your onboard atomic clock, which measures time in nanoseconds, ticks forward. 1 nanosecond passes for you. But here's where relativity gets absolutely bonkers. Because of time dilation, that single nanosecond you experience could correspond to thousands or millions of years passing in the outside universe. Your brain can't process a nanosecond, but if your consciousness was somehow stretched across that moment due to quantum effects or the weird geometry of space-time, it might feel subjectively longer. Some physicists theorize that consciousness near a black hole singularity could experience time non-linearly, meaning that nanosecond might contain an entire lifetime of subjective experience. You could live, love, build civilizations, and watch them crumble, all in the time it takes light to travel 1 foot. Once you're past the event horizon, the rules of reality take a coffee break. Space and time swap properties. Seriously. Outside a black hole, you can move freely through space, but you're dragged forward through time whether you like it or not. Inside a black hole, you can move freely through time, but you're dragged inexorably toward the singularity through space. The singularity becomes your future, not your destination. You can't avoid it any more than you can avoid next Tuesday. Now, in our nanosecond of experience, what would you actually see? This depends on what happens inside black holes, and spoiler, nobody knows for sure because everyone who's checked hasn't sent a postcard back. One theory suggests you'd see the entire future history of the universe compressed into an instant. The stars going dark, galaxies colliding, the eventual heat death of the universe, all of it playing out on the cosmic equivalent of a PowerPoint presentation on fast forward. Another theory involves firewalls, a wall of high-energy particles right at the event horizon that would incinerate you instantly, which honestly seems rude. There's also the possibility of wormholes. Some solutions to Einstein's equations suggest black holes could be connected to white holes, theoretical opposites that spew out matter, in other parts of the universe or even other universes entirely. Your nanosecond could involve getting yeeted through a tunnel in space-time and emerging somewhere or somewhen completely different. Maybe you pop out in a universe where pizza is considered a vegetable. Oh wait, that happened here. Maybe you arrive at the Big Bang of a new cosmos. Or maybe you just end up in New Jersey, which might honestly be worse. Okay, real talk time. For all this cool theoretical stuff about experiencing eternity in a nanosecond, there's one tiny problem. Spaghettification would absolutely ruin your day. See, even in a supermassive black hole, once you get close enough to the singularity, tidal forces become catastrophic. Tidal forces are the difference in gravitational pull between your head and your feet. Near a black hole, if your feet are closer to the singularity than your head, they experience significantly stronger gravity. This difference literally stretches you like taffy. Your body would elongate into a thin stream of atoms, hence spaghettification. It's the universe's way of turning you into cosmic pasta, and there's no amount of stretching at yoga class that prepares you for it. The process is violent and absolutely fatal. Your bones would snap, your cells would rupture, and eventually you'd be torn apart at the molecular and atomic level. The timeline for this depends on the black hole's mass. In a stellar mass black hole, spaghettification happens before you even reach the event horizon. In our supermassive black hole, you might survive crossing the event horizon intact, but as you fall toward the singularity, it's inevitable. So that nanosecond of experience, it might be spent in unimaginable agony as your body is converted into a one-atom-wide strand of what used to be you. Fun! But here's a weird silver lining. Some physicists think that quantum effects near the singularity might be so extreme that matter doesn't behave normally. You might not spaghettify in the classical sense. You might instead quantum tunnelly dissolve into a probability cloud, which sounds prettier but is probably equally fatal. Either way, you're not coming back for dinner. Now we hit the part that makes physicists argue at conferences and throw academic shade at each other, the black hole information paradox. According to quantum mechanics, information can't be destroyed. Everything about you, your memories, your atomic structure, that weird dream you had about being chased by a sentient burrito, all of that is information encoded in the universe. But black holes apparently do destroy information by swallowing it beyond the event horizon where it can't escape. This contradicts quantum mechanics, and the universe doesn't like contradictions. It gets passive-aggressive about them. Stephen Hawking spent decades on this problem and eventually proposed that black holes emit radiation, now called Hawking radiation, which slowly causes them to evaporate over trillions of years. As the black hole evaporates, the information might be encoded in that radiation, meaning it's not truly destroyed, just scrambled, like the universe's worst encryption system. So what happens to your nanosecond of experience? One theory is that all the information about you gets encoded on the event horizon itself, like a hologram. From the outside universe's perspective, you never fell in. You're smeared across the surface of the event horizon as a two-dimensional information pattern. It's called the holographic principle, and it suggests that our entire three-dimensional reality might be a projection from a two-dimensional surface. Your nanosecond in the black hole might be eternally preserved as a holographic recording on the event horizon, playing on loop for the rest of time. You're not dead, you're not alive, you're a cosmic TikTok video stuck on repeat. Alternatively, if there are wormholes or baby universes spawning from black holes, your information might seed an entirely new cosmos. Your nanosecond of experience could be the founding moment of a new Big Bang, and you'd be the unwitting creator deity of a new reality. No pressure. Let's bring this back to the human level. Forget the math and the theories for a second. What would you, as a conscious being, actually experience in that nanosecond inside a black hole? The honest answer is, we don't know. Consciousness is barely understood in normal circumstances, let alone near a singularity where physics breaks down. But we can make some educated guesses. First, your perception of time would be utterly shattered. That nanosecond might be experienced as an instant, a flash of light, a moment of terror, and then nothing. Or, due to extreme time dilation and whatever quantum weirdness happens near singularities, it might feel like hours, years, or even longer. Your brain wouldn't be functioning normally. Neurons require time to fire, and if time itself is doing backflips, your thoughts might fragment, loop, or experience simultaneity. You might experience your entire life at once. Birth, childhood, first kiss, that time you ate cereal with water because you were out of milk, your current predicament, all overlapping in a singular moment of consciousness. Some theories suggest you'd experience something like the universe's perspective, seeing all of time and space at once. Others think you'd experience nothing at all, that consciousness would simply cease the moment quantum decoherence tears your brain apart. There's also the possibility that you'd hallucinate wildly. The brain, when deprived of normal sensory input and experiencing extreme stress, generates its own reality. Near-death experiences, alien abductions, and mystical visions all seem to involve similar brain states. Your nanosecond might be filled with whatever your dying brain decides to conjure. Family members, geometric patterns, a comprehensive explanation of why the final season of Game of Thrones was like that. The experience would be utterly unique and completely subjective, and we'd never know about it because, again, you're not coming back. So what if you spent a nanosecond in a black hole? You'd experience the universe's most extreme physics laboratory, where time, space, and reality itself become suggestions rather than rules. That single billionth of a second could be instantaneous oblivion, or it could be an eternity of experience, depending on perspectives we can barely comprehend. You'd either be spaghettified into cosmic noodles, encoded as holographic information on an event horizon, or possibly yeeted through a wormhole into another universe where you have to explain YouTube to aliens. The beautiful and terrifying truth is that black holes represent the limits of our understanding. They're places where our best theories break down and admit defeat. And maybe that's okay. Maybe the universe is supposed to have places we can't fully explain, regions that remain mysterious and humbling. Before you go, smash that subscribe button because apparently we're all falling toward our own personal event horizons called the future, and we might as well fall together. Hit the notification bell so you don't miss our next video where we answer, what if you lived on a planet orbiting a black hole? And here's a question for you. If you could spend a nanosecond experiencing anything in the universe, would you choose a black hole, or would you pick something that doesn't involve certain death? Drop your answers in the comments below. I'm Alex, reminding you that the universe is weird, physics is wild, and thank God we're all safely watching this from outside the event horizon. See you next time, Space Cadets.